Alright, let's look at number 3, which says tangent to the fourth of x equals tangent squared of x times secant squared of x minus tangent squared of x. Alright, same thing as you start off any other identity is basically ask yourself which one looks the most complicated. In this case, the right-hand side looks like the most complicated one. If you pay attention, the right-hand side has something in common with both terms. And whenever you have something in common with both terms, it's always best that you go ahead and factor. So in this case, what do they have in common? Let's look over it again. They have a tangent squared of x in common, so I'm going to factor that out. When I factor that out, I'm left with tangent squared of x outside, and in the parentheses I have secant squared of x minus 1. Alright, so let's check to see if we factored correctly. Remember I said all you do is just redistribute this tangent squared of x to everything inside the parentheses. Tangent squared of x times secant squared of x is tangent squared of x secant squared of x. Tangent squared of x times negative 1 is minus tangent squared of x. Okay, let's do a different way to help you factor, because some of y'all really have trouble factoring. You decided that you're factoring a tangent squared of x. Well, let's take this first term. We already kicked out the tangent squared of x to the front. Now you always get stuck as to what's left in the parentheses. Remember I said factoring is a fancy word for dividing. So if you divide this first term by tangent squared of x, what's going to happen to the tangent squares of x's? They're going to cancel out, which will only leave you with secant squared of x. If you divide this second term by tangent squared of x, you're going to be left with just 1. And likewise, you also keep your sign, so that's exactly what I did. I brought it down. Alright, your next step is to go ahead and put everything into terms of sines and cosines, if you can. But let's start off with the parentheses first. The parentheses has secant squared of x minus 1. If you remember correctly, and I'm going to star it, we have an identity that says, and I'm going to type it, sine 1, it's 1 plus, let me get rid of that. Sir. Okay, 1 plus tangent squared of theta. In this case, we're going to have x's equals secant squared of x. Alright, so I want my secant squared to be with my 1 according to this step right here. So that means I have to move this 1 to the other side. When I move the 1 to the other side, I have a new identity which now will be tangent squared of x, and I'm going to retype it here, equals secant squared of x minus 1. Alright, so now let's take a look. Is this expression anywhere in my factored out equation that I have up here? I believe so, and it's right here. Now I can substitute for what it's worth, and this is now worth what? Tangent squared of x. Alright, so therefore, my new equation, or my new part of this verification, is going to read tangent squared of x. So we have tangent squared of x, and then in parentheses you said this part right here is now tangent squared of x also. So let's go ahead and type that in. Alright, so I basically have tangent squared of x times tangent squared of x. Well, we can basically multiply those out, and when you multiply tangent squared times tangent squared, you should get what? Tangent to the fourth of x. Alright, let's take a look to see if this answer that we got matches up with the opposite end of the original equation, and I believe it does. Therefore, we can finish off our verification and say, therefore, tangent to the fourth of x equals tangent to the fourth of x. Alright, any questions on that? I'm going to give you some time to go ahead and digest that. Okay. We're going to do one more, and then after that, I'm going to have an assignment that I would like my sophomores and juniors only to go ahead and do. But before I go into detail about that, I'm going to do another example, and that will be example number 4.